Hello everyone and welcome to today's presentation sponsored by Seal Aftermarket Products. We'd like to thank them for sponsoring us. It makes it available for everyone to attend the webinar. I'm going to play you a short video on their products.
Seal Aftermarket Products engineers and manufactures Toledo Transkit with the rebuilder in mind, including everything you need to get the job done right. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment, plus all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. At Seal Aftermarket Products, we don't just make kits, we make kits better. Ask for Toledo Transkit by name.
Okay, if you have any questions or comments about the webinars or any ideas you'd like to send in to us for future webinars, just email them to webinars@atra.com. If you have any questions during the webinar, please feel free to text them to me and I'll answer them the best that I can. For some new guys that may be sitting in on this webinar, you should have received an email that looks something like this. This is your invitation to register for the time zone that you wanted to attend. In this email, you'll see the word "here" in red. You would need to click on that, and that would give you the handout material. If you didn't receive it, or you didn't click on that and get the handout material, just go ahead and send an email to webinars@atra.com. and someone there will make sure that you get it. Also, you can join our mailing list, so you'll get this email for future webinars. At the bottom left corner, if you click there, or if you want to click on the right and send in an email address of someone who you think might want to attend. If you have any issues with something on the webinar that you don't see in the handout, in the upper right corner that you see here, this is basically what your screen should look like. There'll be a little camera icon. Just click on that. It'll take a screenshot of that slide and put it right on your desktop. Today's presentation will be talking about the RE5R05A. This transmission has been covered in several earlier seminars and bulletins, but what I like to try to do when I do these webinars is I try to add as much new information that hasn't been seen before in other presentations. So hopefully I can get that done for you today. This transmission came out in about mid-2002. Obviously it's a 5-speed rear-wheel drive. It was only found in the Infiniti Q45s up to mid-2004. So from 2002 to about mid-2004, you'll see it only found in the Infinitis. What's kind of important is there's many different gear ratios on this transmission based on the year, make, and model. So this ID tag that you see bolted to the case right here is really important to identify what unit we're working with. So try not to damage that or lose it. It's bolted right there at the back of the case, close to the extension housing. Here's all the model applications that have this transmission in it. I tried to update this to the latest year, which is this year. And as you can see, Kia uses it also, and Nissan. So you'll find that in your handout. Also, there's some models listed here for the European market for the guys in Europe that are attending the webinars. Internal component location, we have 3 driving clutches, and we also have 3 brake clutches, 3 sprags, and 1 brake band. The recommended fluid for this transmission is a part synthetic. It's called Matic J. There's other alternatives that you can see listed here that you can use instead of using the OE type. Just recently found out that Matic J fluid is no longer available. It's been replaced by Nissan with Matic S. A friend of mine from CVC Converters gave me a call the other day, said had 2 of his customers with Pathfinders that had a shutter and lockup. Now they use 2 different aftermarket clutches in the converters, so we're not sure exactly which one or if both could be causing this issue. Now, the shop was only using Matic J. They don't use anything else, but now that it's no longer available, they purchased the Matic S fluid, and still both converters still shuttered. They actually contacted Steve Younger at Ratio Tech, and he stated that he's been battling this issue since Matic J fluid has been discontinued. Now, the shop was suggested to use Honda fluid by Steve, and it actually cured both of the both problems of the shutter with the lockup. So I want to thank Steve and Tim for the heads up on that. Now, in your shop, if you're not having this issue with whatever converter supplier you're using, on whatever fluid you're using, if you're not having an issue with it, you don't need to change anything. It's just a little heads up if you do run into a problem. It seems that the Honda fluid is straightening it out, so the regular Honda automatic transmission fluid. This is the component apply chart for the floor shift models, and there's also a different clutch apply for the column shift models. The only major difference here you'll find is in the manual mode when you shift it in the different manual detents. The adaptive strategies should be performed on this transmission before doing any road tests. Some guys aren't doing that. If it's working for you, that's fine, but just keep in mind that during the initial road test after installation, without doing the adaptive strategies, if you feel shifts are bumpy or downshift clunks, you may have some slight flares that go away after driving it. Don't forget that during that relearn, you could actually be damaging the clutch that you just installed. So you have to use a watch if you're going to do this procedure, because as you can see here, they want you to turn the ignition on, wait 2 seconds, turn it back off, wait 10 seconds, and then do the same procedure again. Now, obviously, if we don't do it within the right amount of time, the adaptive strategies won't be reset. Like the idle air volume learning, you have to make sure your battery voltage is up to where it's supposed to be. Engine coolant has to be at operating temperature. Pop neutral switch has to be working. Vehicle has to be stopped. Transmission operating temperature has to be also at the right temperature before doing anything like this. One of the things I want to mention here is that the electric loads have to be off. Any loads like for AC, headlamps, rear window defoggers, things like that. Now, on vehicles that are equipped with daytime running lights, if you want to disable that, just press the parking brake before you turn the ignition switch on. This should keep the daytime running lights off. Also, make sure that the steering wheel is pointing straight ahead in the neutral position. Here's some more step-by-step adaptive strategies operation relearns to do. Again, these are all critical as far as the amount of time. Once you're finished, as you can once you're finished, you should hear the throttle motor move on the app sensor. So we want to make sure that that is working completely after we do the strategies. If you don't hear that motor move, obviously one of the steps wasn't done in the right time allowed for it, and you'll have to go back over and start again. I like to put the TCM inputs and outputs in the handout material. If we're having an issue with an adaptive strategy not wanting to work, or issues with relearn, or a code that won't go away, we have some sensors that we need to look at. Like, for example, this ASCD, that's the automatic speed control device. Sometimes guys get confused at actually what this means. It's basically the steering column and any speed controls in the steering column that would affect the transmission, like cruise control or the overdrive cancel signal. That's all done through the steering column. Here are the list of the outputs from the TCM. Also, in fail-safe mode, this transmission could actually be locked in second, fourth, or fifth, depending on the actual failed position. The customer may bring it to you complaining of a slipping or poor acceleration, Obviously, the transmission's stuck in a higher gear to make feel that way. Some of the things that can actually cause fail-safe on these vehicles, we've seen them at times where the wheels will get into ice or snow and then slip real quick and grab. That could actually cause it to go to fail-safe. Now, if that does happen, basically just turn the ignition key off for about 10 seconds, switch it back on, and everything should return to normal. And you'll also have the pressure switch outputs to check on your scan tool data if you want to check if it's in fail-safe or not. This is the Type 1 valve body system. It's easily identified by the two blue connectors. Now, this system was only found in the Infinity models up to mid-2004. After that, any models for Infinity or Nissan received the Type 2 system, which has the TCM on the valve body. Now, the TCM is not located on this valve body. It's either going to be by the steering column or next to the ECM in the right kick panel. What you're looking at in the middle of this photo here is the shift control unit. If you actually look closely at the middle section of that when you're working on one of these, you'll actually see the imprints of the computer chip that's in there. What this thing actually does is it's set at the factory. So the factory, when they do the initial drive on the vehicle, the information on the hydraulics and the shift pressures for the solenoids are all set and put in that shift control unit as the basic settings. Now, when your transmission is test driven, all that input in torque and characteristics of the shifts or any engine loads, all that data is stored there. Once you drive the vehicle after rebuild, the TCM is going to look at the data that's going, the load and the way the transmission is shifting, and it's going to use that information that's stored in the shift control unit to help the transmission do its relearn. Now, a lot of times the shift control unit is actually mistaken for the TCM. Now, the TCM is not located on that one. It's actually located on the outside. Subaru uses a similar system. They've never gone to the system with the TCM on the valve body. So this Type 1 system has been in Subarus up to present. They refer to the transmission as a 5AT, and the shift control unit is actually referred to as the memory box. Kia models use the same type of system on theirs, and they refer to that unit as a sub-ROM. This is the Type 2 early valve body. As you can see here, the easiest way to identify it is the cast for the unused forward brake solenoid. The hole is there, but there's actually no solenoid that goes there. The other way to identify this system is the single green internal connector, and that's your TCM located right there in the middle. That little tin roof that you see in the center, that's actually a heat sink for the TCM. Now, this TCM has both of the input speed sensors in it and the pressure switches. Those are all part of the TCM. The rain sensor, output speed, and temp sensors and solenoids are all connected separately. Now, obviously, the Type 1 and the Type 2 are not interchangeable. Now, this is the Type 2 late system. The quickest way to identify this is you'll notice the first thing is the hole for the forward brake solenoid that was not used is casted over. It still has the same single green internal connector, but the TCM with the pressure switches and sensors are the same as the Type 2 early. Now, they say that you're not supposed to interchange these. I've actually done it in the shop. We've had customers that couldn't or didn't want to pay for a brand new one. I was working at a shop that had several of these that were like new sitting on the shelf. We actually swapped one out. The only problem that the customer had was it would work fine if the shifter from park all the way to overdrive detent, but none of the manual detents worked. So obviously we pulled this from a vehicle that had a floor shifter, and his had a column shifter, so that part didn't work. The customer was happy just the same because he saved some money, and he basically said he never uses anything but the overdrive detent anyways. So that did work. What we were lucky about was the vehicle that the valve body we put in came out of must have had the same ratio in it, because it didn't cause any ratio codes. Now, what you may find right around 2007, if you buy one of these valve bodies new, you'll notice that the computer changed from a Bosch type to a Hitachi, and what you'll find is there's no valve body gaskets on that valve body brand new from the dealer. This is the early 2002 to mid 04. This is the Type 1 system with the external TCM. These are all your connector views. So on this vehicle, we could actually take our DVOM and do some checks on the solenoids. We could look at TCM voltage signals for the clutches, for the solenoids themselves, or the switches. We can watch all that with the multimeter. This is the mid 04 and up. This is the one with the internal TCM. As you can see here, but the only thing you can check for the DVOM is battery voltage, CAN signal, grounds, and things like that. If we had to check any solenoids, we'd have to use a capable scan tool to look at the data stream. There are 7 solenoids on the valve body. All the solenoids except for the low coast brake are which is 23 ohms. All the others are 3.3 ohms. Obviously, on this Type 2 system, you would need a scan tool so you can monitor the data to see the solenoid amperage ramping from 0 to 0.8 amps, which is about what they normally work at. For example, the TCC solenoid will ramp from 0.2 to 0.4 amps during the time the converter is slipping. Once it's fully locked up, you'll see the solenoid amperage go to like 0.4 to 0.7. All the other solenoids work the same way. Normally you'll see the clutch solenoids ramping from 0.6 to 0.8 when the clutches are disengaging, and then you'll see them actually turn off to like 0.0 to 0.05 amps when the clutches are actually engaged. Here's your solenoid apply chart. As you can see on the right column, the low coast brake solenoid is basically only used in manual 1 during coast down for engine braking. The pressure switch ID and functions located here. This is the Type 1 system on the left and the Type 2 system on the right. As you can see, the pressure switches are part of the TCM on the Type 2 system. And the legend at the bottom of the page identifies how what each pressure switch is monitoring and how it works. I put 2 charts together for this, the pressure switch apply charts, one for the floor shifter and also one for the column shift models. This is the trans temp sensors. There's 2 of them. One of them is actually part of the rain sensor, as you can see in the upper right. There's a little blow-up of the actual location for the temp sensor. That's part of that rain sensor there. You also have the pinout. You can go to the pins on the rain sensor there and do a test with a multimeter. And same thing with the output speed sensor. You can see that's connected to that rain sensor. So we can actually do a test on that one also. And we'll show you that in just a bit. Now, the temp sensor 1 is checking the sump temperature, the oil temperature in the pan. They usually runs about 6.5 kilo ohms at about 68 degrees Fahrenheit. The temperature sensor number 2, that's actually monitoring the cooler hydraulic circuit, well, basically torque converter temperature. That one is separate from the TCM. it's about 4 kilo ohms at the same temperature as 68 Fahrenheit. What you'll find on some late models, like mid-2007 to 08, some models will they've actually eliminated the number 2 temp sensor. There are 2 turbine revolution sensors, and you can see the early type 1 on the top, and obviously the one on the bottom is the type 2 system. The one on the top, well, both of them actually, the turbine sensor 1 is actually monitoring the front sun gear shell, and the turbine sensor 2 is monitoring the input housing front planetary shell. Now, the way the factory tells you to test these is either do this with a multimeter on the Type 1 system, or obviously a capable scan tool for the Type 2. At about 31 miles an hour in 4th gear, they want you to back off the throttle so the TPS is closed, or the accelerated pedal position is closed, and the sensor should read about 1.3 kilohertz. Sensor number 2 at about 12 miles an hour, same thing, we're in 1st gear. Closed throttle, it should read about the same, 1.3 kilohertz. This is the output shaft speed sensor. This is the one that's actually plugged into the rain sensor. And we could actually do a bench test on this. We have the transmission case and output shaft on the bench. We could actually jump power to pin 1, ground pin 3, and with our DVOM, we could actually check the DC hertz of the signal, DC hertz signal on pin 2, just by turning the shaft. Here's our park neutral position sensor, or rain sensor, whatever you want to call it. It's actually called a PNP. As you can see, the diagram at the top left, there's a little tab that on the rain sensor assembly. That tab is bent, and most of them will come bent right out of the box or the package that you bought it in. The metal is pretty tinny, so it's real easy to take your fingers and just straighten it out, but it should be pointing straight down. Down inside the case is an actual pocket for that tab to go to. And there you have the connector view also for the park neutral position switch. This is quite a common problem we get on the tech line. After overhaul, we start the vehicle up and it keeps popping the TCM fuse. And the problem here is you'll notice that there's a jumper harness. Now, this jumper harness has a green connector on one side and a gray on the other. Now, the green connector is supposed to go here into the TCM, and then it swings over and goes to the rain sensor. So the gray side goes towards the rain sensor. Now, the external harness coming in to the TCM has the exact same gray connector as the jumper harness. So the mistake here is the jumper harness gets plugged into the TCM. The external harness actually gets plugged into the rain sensor. And as you know, most rain sensors just open and close or short voltage at different detents to signal the TCM or what gear has been selected. So if we hook the outside external wire harness to the rain sensor, it's obviously going to short the fuse power for the TCM to ground and just keep popping the fuse and possibly setting codes. Talk a little bit about pressure testing this unit. There's been a lot of confusion in the past. Sometimes this tap right here, the front brake band, that tap will actually be listed as the line pressure tap. That's fine. It is line pressure there. If we were going to do a stall test, that's the tap we would use, because as you can see, the front brake band is on in reverse, first, second, third, and fifth. It's not on in fourth. So if we're going to do a stall test, we could do a stall test in reverse at idle and at stall, and the same thing with drive. Now, the confusion happens if you have a problem with fourth gear and you're doing a line test on this tap using it for line pressure. You'll notice that you'll have pressure there all the time until it hits fourth gear. Then it'll actually drop to 0. So don't think that you have a problem with the input clutch dropping to 0, because that's actually the front brake band. The band is on a lot of times and it's inactive, but there will be pressure there, but the band's not doing anything. But the band has no pressure at all in fourth. The only other tap you can check for fourth gear pressure would be this one, but it's actually the direct clutch. It's not the input clutch. There's no tap for the input clutch. So this clutch is actually on in second, third, and fourth. So in fourth gear, you could possibly see a leak there, in pressure there. It could also be caused by part of the direct clutch piston, and we're going to show you that in a little bit. This is the lower valve body from 02 to mid-04. This is the early one. Don't think that something fell out of the valve body itself. This bore is empty. That's normal. On the other side of the valve body, we'll have a check ball and spring with a plate. Want to make sure there's no debris keeping the ball from seating. This is the mid-2004 and later. This is the early and the late is the same. And the third design, I don't have a picture of it here, but the only difference I found in the valve body on the third design as far as the valve lineup is they only have one neutral to reverse accumulator instead of two. Now, keep in mind that the third design valve body went through many changes in hydraulic circuits, and we're going to talk about that in a little bit. And obviously the separator plates are different, so we cannot change the third design with either the early or late second design. The other difference is on the second design here, as you'll see, there's now a valve in that bore. It's no longer empty. And instead of the check ball and spring with the plate being on the other side of the valve body, they've now incorporated it in here in the main valve body. This is the forward clutch accumulator. This is the same and has not changed on any of the valve bodies from the first design all the way up to the third design. You have the valve descriptions in the handout material. The two neutral reverse accumulators, one actually stabilizes pressure for the shift into reverse, and then once it's in reverse, the other one comes into play at that time. Again, the third design has eliminated the one of the accumulators. This is the rest of the legend for the valve descriptions. Now this is the early 02 to mid 04. They have 5 steel check balls. We've identified the check balls for you also. And this is all three. This is the early, the late, and the third design. We'll have 3 check balls, so all those stay the same. The only difference in the third design is some changes in the casting for the different hydraulics. What you'll find in the first design up to 04 is 4 screens like this. After 2004 and up, there's 5 screens altogether. What we want to make sure of is that the screen's open end is facing up towards the valve body. And this is obviously the same for all the valve bodies. Here's an air check diagram so we can air check the transmission. I like to do air checks with 30 psi. I don't like to use full shop air. Even at 30 psi, I don't always trust an air check when it comes to molded pistons. I've had them air check fine on the bench and then turn around and not work right once it's in the vehicle. Now, what we were talking about before is the direct clutch air checks here to the small cavity, and there's another air check for the direct clutch large cavity. This is the same thing as you would have in an old GM 400. We have 2 different applied areas on the piston. One was for third gear, and then obviously both were for reverse. So that's basically the same way that this works. The sprag rotation is located here. The forward sprag at the top, first sprag on the left, and on the bottom right is the third sprag rotation. Total unit end plate should be about 10 to 22 thousandths. And as you can see here, we just took the H gauge, put the legs on the area of the case with the pump mates to it. We set our metering rod down so that it actually touches one of the bearings on the thrust bearing. Flip it over, do our measurement. You have all the factory part numbers for the selected races along with the actual thicknesses. When it comes to clutch end play on these transmissions, when they first came out, Lance and I actually worked on this for a few months, dealing with techs online to come up with the correct end plays. The problem was that several factory manuals were way off. The clutches were way too loose. We had all kinds of clutch complaints, shift complaints to the clutch end play. So we used factory information, some of our own. We looked at some of the ATSG information, Transgo, Ratio Tech. We compiled all that, and working with guys on the phones, we actually came up with this set of measurements that worked really well. What you're going to find is that some of these clutches have no selective components other than the reverse backing plates for the reverse clutch. So we give you the part numbers for those and the thicknesses. So if we're dealing with one of these other clutches, you may have to shave one side of the clutch and put it with another clutch to try to make up some of the clearance. What we are hearing right now on the tech line, some 2008 and later models, basically that third design valve body, we're starting to find some of those complaints that the aftermarket kits, the clutches are too thin and then leaving the clutch end plate too loose. Again, you may have to shave a clutch to try to make up the difference, or obviously you'd have to buy OE clutches. This is the anti-rattle spring location for reverse brake clutch. If it comes in, if the vehicle comes in and that's missing, you may want to get one and put that in there. Because you know as well as I do, once the customer's paid for the transmission, he's going to be listening and looking for anything. And he's going to say that that noise wasn't there before and it is now. So basically, this is a good time to make sure that that spring gets put in there. These are your torque specifications for the whole vehicle, for the whole transmission rather. What I found so far is there's 4 different torque converters for these vehicles. Some will have 4 bolt pads and one of them will have 6. The one that takes 6 bolt pads is usually for Kia applications. And as you can see, the other applications here for the ones with 4. Now you'll notice that all 4 of them are different heights. So you have to be careful when your supplier drops off the converter. Make sure you check it against the core before you release the core to them. Well, if there's 4 different converter heights, obviously there's going to be some differences in the stator shafts and the input shafts. As you can see here on the left, there's 2 different input shafts. The long one is usually found behind the Armada and the Titan V8 motors. All the others will have the shorter shaft. Same thing here with the shorter stator shaft and the longer one. Now, whether you have either one of these stator shaft lengths, I found both these non-step and step supports on either one of these shafts. So be careful when you interchange parts that you make sure you put in what you took out. So let's talk about planetary assemblies and interchange. There's quite a few differences in tooth counts in some of these items. For example, we have here the input shaft. Either length, short or long, could have either one of these tooth counts. There's only about 4 teeth difference between the two, so putting them side by side might not be an easy way to identify it. You may have to count all the teeth on it. What we found, the general rule, is the 5-pinion steel planets are mostly found in the truck vehicles. The 4-pinion or aluminum planets are found in cars. We have a 4 and 5-pinion center planet. And take a look at this center ring gear. We have 1 tooth count difference between them. So there's 2 of them. So You might be able to put one up against the other and look down through the inside to see if the teeth match up, but I would still count them to make sure. Same thing with the rear planet. We have a 4 and 5 pinion. And on the center side gear, there's two different tooth counts. The one with 42 goes behind the goes with the 5 pinion center planet, and the one with 43 goes to the 4 pinion. Now, looking at the rear ring gear, you can see there's two of them that are only one tooth difference, and then there's one of them that's 110 teeth. So you can see mix and matching these can cause all kinds of problems and all kinds of ratio codes. So what does that come up with? Well, we've come up with 3 different ratio combinations for all these vehicles. There's only 3. So if I swapped and put a B ratio transmission into an A, the computer is going to give me ratio codes for every gear except 4th. Because 4th gear is a 1-to-1 on all 3 of them. So these are the 3 different ratios that you'll find. Here's the chart to identify that if you have this ID tag, like we mentioned before, this is important. That ID tag is going to tell you which chart, which ratio chart goes to that vehicle. So obviously if we have a 06350Z with that ID tag, it's going to be ratio C, or if it's this one here, it's going to be ratio A. You'll notice that some of these on the 2-wheel drives, it may have 2 different ID tags, but they both still take the same ratio. And the same thing here in 4-wheel drive. There will be some models that will have 2 different ID numbers, but still take the same planet ratio. Now, these ratios can be actually found on Mitchell's or ALLDATA. I spent a long time going through all of the information I could find to update this chart to the latest model years. Now, in this chart, what you're going to notice is, I have an asterisk here, the 2009 Pathfinder, the 4x4 ID tag, there's 2 different numbers that fit the VQ40DE engine that take the A ratio. So what you're looking at here is you'll see 3 numbers listed. These 2 actually go to this engine, and that would be an A ratio. Now this last number on the right, that's this one here, it goes behind the VK56DE engine, and that would take the actual B ratio. Now the rest of these, the last 3, these 2010 to 12 Pathfinders with the 4x4 tag, these are just separated by a /. So the first number would be an A ratio, the second number would obviously be the B ratio. Nothing fancy on this chart. These are all pretty much set the way they are. And then on the last chart I have here, just this model in the 2x2 tag. If you have a 4x2, rather 2-wheel drive, the only thing different here is we have the 2 ID numbers separated by a /, just like we've seen before. So the one on the left would be A, the one on the right would be a B ratio. Sealing ring issues on this transmission have been probably the biggest headache to date as far as tech call goes. We get several tech calls. A lot of guys don't want to use the aftermarket rings that come in the kit. The bottom line is the aftermarket rings are the same ones that Nissan is putting in their kits. The big issue here is not the rings themselves, but how they're handled. Now, even if you had the OE ring and you took it off, by the time you remove this ring all the way up the shaft and then put it back, you may distort it. And it doesn't take much. This is kind of a hard plastic material, and it does not form back to memory very well at all. So it's not no heat is going to help it conform to the bore that it fits in. So either the aftermarket or the OE rings, if they're distorted, they'll give you all kinds of shit problems. Now, in the aftermarket, as far as remands, a lot of the remand facilities are using the 47 RE plastic input shaft rings, much easier to work with. They go on there and they work very well. On the center sun gear shaft, They're using the AODE metal nickel plated rings from the output shaft of an AOD. They work very well here. These are the only two real locations that I feel that these rings should be addressed. Now, some guys are saying that the center support rings are giving them problems, and they're using rings cut to size from a 4L60 servo. I personally haven't had that problem, and I've talked to a few remans that are just using the OE or the aftermarket rings and not having an issue there. This is something new I've been running into. Several Virgin units have been showing up at shops and reman facilities with the middle sealing ring missing. This goes to that direct clutch. And this is the clutch that has the two cavities. This is commonly found in the mid-2008 and later Infinity vehicles, according to the information I'm getting from one reman facility. These vehicles are also the ones that have that third design valve body. Now, if you're doing an air check on this, you'll find that the large cavity is fed through here, and it comes out through this top one to here, and then the small cavity is fed through this way, and this is the small side of the piston, and this is the large side. Obviously, with them leaving the ring out, we're filling up both cavities at the same time. So that's the only thing I can see that they're doing here. This is very similar to what we used to do with the GM400s. By taking the sealing ring off that one or the inner lip seal. So now on the early design, like the System 2 design, the early and late one, remember, like I said before, the 2-3, both of these cavities are filled during second and third. Once this go to fourth, it'll take the pressure away from the large cavity, and it just keeps the small cavity filled. So a lot of times what happens is a guy will have a problem in fourth gear, slip, and the input clutch is the only clutch that comes on in fourth. They'll be chasing a leak in the input clutch that's not really there, and the problem is actually the small cavity. So with both cavities filled in second and third, you don't feel a problem. Once they release the pressure on the large side, the small cavity the only thing holding, so if there's a leak here, it will show up in fourth gear. So keep that in mind. One of the other changes that I've seen happening is that we have several calls on which support takes the thrust washer with the tabs and which one doesn't. That's pretty easy. The ones with the tabs that you see here on this thrust washer would have the notches cut out in the support. So if you don't see any notches here, it doesn't take the washer. There are some models, and I'm still working on which ones will have this bearing and which ones won't. I have talked to some of the